All right, I'm going to get started now. Thank you to all of the attendees here, as well as all of the panelists and those who have helped put on this event. My name is Joni Manhennet. I am a Civic Spark Fellow working with the City of Milpitas this year. And today, to celebrate Earth Day, we have Bill Middlecamp. Before I provide you all with Bill's introduction and bio, I just want to highlight some of the work for Earth Month that's still upcoming. We have already been really impressed with the engagement that you all as Milpitas community members have provided. And there's still a couple opportunities in our near future for you to get involved with climate action in Milpitas. First off, if you are social media inclined, we have a series of weekly challenges running on Instagram that some of our interns have been working very diligently on. So if you follow the Instagram account at MilpitasRec, all one word, then you can get involved with some of the challenges that earn prizes that you can pick up at our Public Works Department. So that is the flyer you'll see on the left side of your screen. Now, tomorrow, we also have the opportunity for you to come by and pick up a free litter kit. If you could please go online and register for a free kit, that would help us making sure that we have all of the necessary materials. Then this Saturday, Milpitas Sanitation is hosting a compost giveaway. On May 1st, we have a vermicomposting workshop. And finally, if you would like to get involved with the update to the city's climate action plan, learn a bit about the mitigation measures under consideration and share your vision for a sustainable Milpitas, you can register online or view our dashboard at climateactionmilpitas.com. So with all of that, I'm now going to flash over to the introduction and bio for Bill Middlecamp, our presenter today. Bill is one of over 20,000 trained climate reality leaders from over 150 countries and is a trained En-ROADS facilitator. Bill has a Bachelor's of Science degree in meteorology, a Master's of Science degree in computer science, and is a commissioned United Methodist Earthkeeper. For over a decade, Bill has participated in organizing and delivering presentations on environmental issues related to health, economics, science, and solutions to the harmful changes we are seeing. Bill is retired and dedicates himself to teaching about our degradation of the critical life-sustaining properties of the environment. So with all of that being said, please join me in welcoming Bill Middlecamp to present to us today. And for the remainder of this presentation, we have disabled the chat feature, so ask your questions in the Q&A, and both myself and then Linda Grant will help you to get those questions answered. Thank you and enjoy.
Thank you, Johnny. Let me share my presentation. This is the famous blue marble image taken nearly half a century ago by our lunar astronauts. It shows our precious Earth from space and reminds us, excuse me, I have to move the people off of here. It reminds us that we all share this one home. I want you to think about the vast blackness of the universe surrounding us. The Earth is a tiny speck compared to all that, but it's the only place we have to live. Think of the Earth as a small lifeboat in the middle of the Pacific, thousands of miles from land. No one is coming to save us. Without the lifeboat, we will all surely drown. That lifeboat has sustained us throughout 1 million or so years of human existence, and we know it can sustain us forever in terms of our myopic view of time, but for some time now, we've been drilling holes in our boat for short-term gains. Even now, those gains are steadily getting eclipsed by real losses, which is a portent of a dark future if we don't act now to change, to change our profligate ways. In all the debate about the climate crisis, there are only 3 questions remaining. Must we change? Can we change? And will we change? Let's take them one by one. Must we change? Well, we're using this thin shell of atmosphere surrounding our planet as an open sewer, and we're spewing all the man-made global warming pollution into it. Now, the natural greenhouse gas layer is good for us. Without the atmosphere and oceans, the average temperature of the Earth would be about -6 degrees Fahrenheit. That's the straightforward physics of radiant energy streaming in from the sun and streaming out from the Earth into the cold blackness of space. But the atmosphere acts like a dam and a river to slow the outward flow of energy and raise the average surface temperature to about 59 degrees Fahrenheit. And at this balance point, the world has existed as we know it for thousands of years, with a particular balance of liquid, ice, and atmospheric water vapor that support a favorable climate.
Bill, I'm so sorry, if I could jump in here. At the moment, we are seeing the presenter notes rather than the slide. I did see the slide earlier though, so I know you can get it to work, but there we go. Thank you.
Sorry about that. Thank you.
My pleasure.
For thousands of years, human society has been built up on the foundation of a fairly stable climate. Come on. There we go. The greenhouse gases in our atmosphere are rising because we're spewing 152 million tons of man-made global warming pollution into it every day, treating it like an open sewer. These extra greenhouse gases come from lots of different sources, such as landfills, transportation, burning forest and cropland, animal agriculture, and even the thawing permafrost is playing a role now. This last one is particularly worrisome because it's the start of a runaway tipping point that is very hard to stop. But the biggest source by far is our reliance on fossil fuels, and since World War II, that's been going up dramatically. Now, isn't climate always changing? Why does it matter if human activities are causing it now? Natural climate change is slow, happening over thousands of years, which allows living things to adapt. The asteroid that hit the Earth 65 million years ago changed the climate in an instant and brought an end to the reign of dinosaurs. The Anthropocene, the name for this era when human activities are the biggest driver of changes to our planet home, is more like that asteroid than it is to the Earth's natural cycles of change. In the Anthropocene, temperatures are going up very fast, changing measurably in a fraction of a human lifetime. It's unmistakably clear, and the scientists are telling us that last year was either the hottest or second hottest year ever measured with instruments, neck and neck with 2016. 20 of the 21 hottest years have been since 2001. The 6 hottest years have been the last 6 years. The data show an undeniable fact. It's getting hotter on the Earth. Now, this is a bell curve, which is what you would see when you roll a pair of dice and plot the results. The number 2 double ones would be on the left, and the number 12 double sixes on the right, both having the lowest chance of occurring, so that's why those endpoints are thin. The number 6 and 7, the normal results, would be in the high occurrence white space in the middle. This bell curve shows normal temperatures as they were in the period between 1951 and 1980. The blue is cooler than average temperatures, the white are average, and the red are warmer than average temperatures, a typical bell curve distribution. Well, in the 1980s, the whole curve shifted to the warmer side. And you'll see in the lower right-hand corner the appearance for the first time of a statistically significant number of extremely hot days. Then in the 1990s through 2008, you see the right side gets even bigger. And in the last 10 years, look at what's happened. The extremely hot days are now more common than the combination of cooler than average and what used to be the normal days. In fact, these extremely hot days now cover more than 200% of the amount of the Earth's surface than they used to cover back in the second half of the 20th century. These extremely hot days are driving many of the consequences we are seeing. But isn't it better if the world is warmer? I mean, some people, especially here in Minnesota, where I'm from, they might think that. But we're seeing the heat go up all over the world. Last year, Miami had its hottest week ever measured. This is Australia at the start of 2020, which is their southern hemisphere summer. Look at Canberra, their capital. They set an all-time high temperature record of 111 degrees. People die in this kind of heat if they cannot escape into air conditioning. Here in Ghana in West Africa, it's already one of the hottest countries of the world. I'm guessing there's no air conditioning in that hut on the right. In April of last year, they set an all-time temperature record of 111 degrees Fahrenheit, 2 degrees hotter than the previous record for their northern border. Now, the people of this region are subsistence farmers. Climate change could destroy their way of life. Then, where will they go? Europe had the hottest year ever in 2019, and all of these countries have set all-time records. Norway is at the top center of this map. I was there in Bergen on the very day they set their all-time high temperature record. Now, this is really shocking. In Siberia, above the Arctic Circle, it went above 100 degrees, 38 degrees Celsius, the hottest temperature ever measured north of the Arctic Circle. Everyone should understand this. Warming produces more water vapor, and that's the fuel for storms. This image of the globe is centered over the Pacific. It helps us to remember that the world is mostly ocean. And in the world as a whole, it's useful to remember that 93% of all the extra heat goes into the oceans, and this disrupts the water cycle. We saw ocean temperatures also hit a new record in 2019, and almost certainly again in 2020. This makes the ocean-based storms stronger. These temperature readings go deep, more than a mile. Look how clear these numbers are. We have to accept this data and follow the science where it leads us. So the accumulated amount of global warming pollution, carbon dioxide, methane, nitrous oxide, and the others, that accumulated pollution is now trapping as much heat energy every day in the Earth's system as would be released by 500,000 first-generation atomic bombs exploding every day on the Earth. That's an unbelievable amount of energy, particularly when you multiply it by 500,000 times every single day. That's what's causing the temperatures to go up and all of the other consequences that we're going to be talking about in this part of the slideshow. All that heat magnifies the amount of water vapor coming off the oceans into the sky. When all of that water vapor comes over the land, the precipitation events increase, and when it rushes back to the sea, the floods and mudslides increase. You can see that all over the world that massive precipitation events are happening more frequently every year. We're seeing rainfall that breaks all records. This dramatic image was taken in Montana. In the US, extreme downpours are now happening 30% more often than in 1948. Globally, these rain bombs are happening 4 times more frequently than they were just 40 years ago. So must we change? Well, where will people go if the weather destroys their way of life? We just saw this devastating storm last spring in the Philippines. More than 500,000 people were affected by it. And did you know that they suffered 5 back-to-back typhoons and tropical storms just in the last part of last year? Much of the country was underwater. A good friend of mine lives there, a United Methodist earthkeeper, and he said that his mother's rice crop was destroyed. People are suffering today, not just in the future. This massive storm barely got mentioned by US News in May of last year. In the Sundarbans, the area where India and Bangladesh join, both countries were hit by supercyclone Amphan. In this region, people live very close to sea level. They are vulnerable because they are very poor. And the people in the river delta there were devastated. There's a lot of outmigration from those low-lying areas. And when they're rescued during the pandemic, it's an extra challenge. Here was one last summer in India and Nepal. 4 million people were displaced by the flooding and the mudslides. This one's China in June. 700,000 people affected in Guangdong province. And in April, this one in Kenya, 100,000 families displaced. This was in Tennessee last spring. This was in New Jersey. By the way, minority neighborhoods and communities are far more affected. This was an image last year in New Orleans. We're seeing the same weather pattern all over the world. As Pope Francis reminded the world powerfully, the poor are the ones most affected, and communities of color are most affected. Here in the United States, the Poor People's Campaign is campaigning against ecological devastation, along with racism and poverty and the other evils they've identified. If you look at the 10 countries most affected by flooding in the United States, 81% of the population is minority on average. I've been asked to talk more about impacts in Minnesota. Now, that's where I live, and this is looking down on our border with North Dakota, showing normal Red River water levels and flooding in April 17th of last year, following an unusually wet fall and winter. We know this river has flooded in the past, but floods are happening more often, not just in the spring. I'm going to skip ahead because in California, you might not be as affected by some of these things. But here's a way to put it in perspective. If you look at the likelihood of what used to be a once in 100-year storm before the climate crisis, they were once in 100 years. Now you get 5 in 100 years. But if we allow the temperature of the Earth to go up by 2 degrees Celsius, we're going to get 20. That's once every 5 years. Now, if you look at once in 20-year storm, the same thing is true. We're going to get 50 of those every year instead of once every 20 years. Let's talk about farmers. There's an old saying that there are no atheists in a foxhole. Well, there aren't many farmers who say that climate change isn't happening because they are seeing it on the front lines. And that's a pattern that's holding around the world. Farmers were hurt in 2019 in the prime farmland of the Midwest. 20 million acres couldn't be farmed because of the massive downpours. My wife and I drove to Santa Fe, New Mexico from Minnesota in January of 2019. As we drove through the Midwest, we saw huge piles of farm products outside of grain bins. I assume they were there at least partly because of the trade war with China. Not long after that, flooding destroyed much of the products, and the swelling of wet products destroyed the bins too. There was $20 billion in damage. That tractor is pumping water out of that field. Seems almost futile, doesn't it? The same extra heat that causes these rain bombs and floods also causes the droughts by sucking the moisture out of the topsoil, so the droughts take place more quickly. The groundwater is used up faster. North America is already being affected by the drought, and the projections in the balance of this century are dire. But the conditions in Central America are already quite severe, and this area known as the Dry Corridor in Central America is the place from which most of these refugees are coming north to the border between Mexico and the United States, which creates political disruption. This is in Europe last summer, showing the dangerously low levels of groundwater there. The 2020 drought in Europe, the Czech Republic, was the worst in 500 years. Parts of Poland, the worst in 100 years. This is Chennai in India, the 6th largest city. In 2019, they almost completely ran out of water. Now, solving these problems is expensive, but not solving them leads to the collapse of governments and the rise of world conflicts. Who hasn't seen the news about massive wildfire losses all over the West? I've been on Zoom meetings where some people were missing because their homes were being impacted by wildfires. Now, that seems very close to me. When we have high temperatures and drought, we also see more fires. Look how closely temperatures and fires are correlated. And the fires have been devastating. This is one in June. This one is in June in Arizona, in California in 2019. Now, it's sort of ironic that solar panels, which are part of the solution for stopping climate change, produce less electricity because of smoke blocking the sun. By the way, that affects the crops too. The same thing was true in Australia at the turn of last year. The smoke from those fires circled the globe. And of course, in the Amazon, these man-set fires are devastating as well. Most fires are set by humans, either accidentally or intentionally, but climate change exacerbates the problems by creating more fuel in wetter cycles and longer windows of vulnerability in dry periods. The Prime Minister of Greece highlighted climate change as fires impacted Southern Europe. Everyone is impacted, but how are the wealthy impacted? Well, insurance, for one. The reinsurance companies are pointing to all these climate-related disasters and telling us that this is completely unsustainable. The cost of these finds its way back to you and me one way or the other. In Minnesota, we have seen our rates go up because of destructive hail. You know, we all know somebody around here who's had a new roof put on at the cost of insurance, provided by insurance because of hail. Minnesota used to be one of the lowest in the nation because of, just not having a lot of weather-related claims, and now we're fourth. Did you know that the insurance industry does not cover risks that are too common? Climate change will have them backing away from some of the things that they have covered in the past. This big hailstorm was just last June in Alberta, Canada, one of Canada's most expensive natural disasters ever. Look at the siding on that house. Let's talk about sea level rise. The heat is also melting the ice in Greenland. This marine glacier turned into water. NASA's estimate of the ice loss in Greenland shows us that it's 4 times faster than they had originally thought. Did you know that NASA can measure this from space with gravitational satellites? It's called the GRACE mission. The same thing is true in Antarctica, where the ice melting has accelerated quite dramatically. Now, when this massive amount of ice in these 2 regions melts, sea levels goes up. The top 10 cities by population affected by sea level are shown here. You see a lot of them in South Asia, but notice Miami on the right. And when you arrange those by assets at risk, now number 1 is Miami. Those are trillions of dollars, trillion with a T. Sea level rise is the reason why this octopus showed up in a parking garage in Miami. Now, sea level rise cannot be stopped with a seawall there because the geology of the area is too porous. Saltwater intrusion is a real threat to their groundwater resources, and this may force us to abandon living there. In New York City and Newark, $130 billion of real estate assets is at risk. Building a seawall is possible there, but it will cost billions. But the people most at risk in these low-lying Pacific Island nations, and in some places, they're already having to move. Our health and security are at risk. Our own U.S. military has said that climate change is a threat multiplier. Climate change creates problems for food and water and health. When people cannot grow their food or earn a living, they move. And the fear of being overwhelmed by refugees leads to the rise of isolationist and authoritarian governments. And refugees, as we saw after the Syrian drought, this has destabilized the political equilibrium in parts of Europe. We have medical emergencies caused by the climate crisis all over the world. Let me tell you about some of the health consequences. Tropical diseases are moving toward the poles, and air travel is one of the reasons why, but the conditions are changing due to the climate crisis, where these diseases can take root and become endemic. Air pollution kills 9 million people a year, and the same burning of fossil fuels that creates the global warming pollution also creates the particulates that cause more lung and heart disease. It also makes people more vulnerable to the COVID-19 pandemic all over the world. More air pollution means a higher death rate from COVID-19. And again, we see this problem show up worse among minority populations and poor populations. Black Americans are dying at a rate more than twice as high as white Americans from COVID-19. Now, there are many reasons, but the climate crisis is one of the principal ones. And please don't forget this. Human life depends on the diversity of all life. We are in danger of losing half of all the living species on this earth in this century. Now, many factors contribute to extinctions, but climate change also plays a part in this. So when you add up all of these costs, And we haven't even talked about ocean acidification or infrastructure or some of the others. I'll add one more. It's the #1 threat to the global economy. For the 4th year in a row, it's been designated as such. Now that's a whole talk in itself, but let's move on. So, do we have to change? Yes, we do. So what about the second question? Can we change? The answer to that question is yes, too, because we have the solutions at hand. And we're going to get into that in the second part of today's event. Let's have a quick look now. 20 years ago, the best projections for wind energy were that we could reach 30 gigawatts of wind energy by 2010. Well, we beat that mark in 2010, and we've kept going. In 2019, we beat it by a factor of 22. Just look at the growth in wind energy. This is exploding because now it's the most economical choice. So wind-generated electricity is exploding on its own for purely economical reasons. With solar, it's even more dramatic. The best estimates 18 years ago were that the amount of solar energy we could install each year might reach 1 gigawatt installed per year by 2010. Well, we beat that mark when 2010 arrived by 17 times over. And last year, we beat that mark by 121 times over. This exponential curve is even steeper than the one for wind and rising even faster. And of course, one of the things that's driving this is that the cost is continuing to come down every single year. It just keeps on getting cheaper. Because the cost of renewable energy continues to come down dramatically. To add some perspective, let me just say that 1 watt of solar generation capacity produces about 20 cents based on prices here in Minnesota, 20 cents worth of electricity per year, and the panels are expected to last 25 years or more. Now, I understand in California, your electricity prices are significantly higher than ours. So to me, that seems like a pretty good investment. Chile has been the best place in the world for solar energy. Look at all of the solar farms that they've built and are approved for construction to begin, and this is a breakout scenario that we're seeing in quite a few regions around the world. It is a cause for tremendous hope. We're seeing a very rapid transition. And we're not going to run out of it because we get as much energy from the sun in 1 hour as all of the electrical needs for the world for a whole year. Renewable energy can be enhanced with storage capacity, which is also developing rapidly, but we don't need as much of this as one would think. Did you know that wind turbines produce more energy at night? Now that seems counterintuitive, but we have the data. This makes the combination of wind and solar more effective for providing a steady source of the energy that we want and need. The projections show that storage is a new trillion-dollar industry, which is going to make solar and wind even more useful. And it isn't just batteries. There are many ways to store energy. In transportation, we're seeing the beginnings of a massive shift to electrical vehicles, nowhere more than in California. I have owned 1 fully electric car since 2012 and 1 plug-in hybrid since 2018, and I can attest that they are great to own and drive. Battery prices dropped by 87% from 2010 to 2019, and according to Bloomberg New Energy Finance, we're about to cross the point where EVs start to cost less than internal combustion engine cars. As electric generation shifts from fossil fuels to sustainable resources, electric cars inherently cut down the production of global warming pollution. And this is another positive sign. So yes, we can change. So the final question, the most important one, will we change? Well, that's partly up to us, but we've got the Paris Agreement. And as he promised, President Trump withdrew the US from the Paris Agreement, but not until the day after the election of our new administration. And President Joe Biden signed on Inauguration Day the 30-day notice to get back into the agreement. So now we're having a summit in the White House in America. President Trump also promised to rejuvenate the fossil fuel industry, but circumstances were beyond his control. As the stock market, shown in blue, was going up, the fossil fuels sector, shown in red, was going down. Fossil fuels have been bad investments for some time. The word is getting out, and we're seeing a huge shift of assets toward the sustainability revolution. Once the sustainable generating capacity is built, the fuel cost is zero. Fossil fuels cannot compete as their costs are always rising. Here's the overall value of ExxonMobil. Here's the value of Tesla, just surpassing that of ExxonMobil. And a lot of these companies now are coming to understand that they are facing a real crisis. Now, this is encouraging. In the US, we're already seeing almost half of our states with more than half of our people moving faster than the Paris Agreement requires. We're seeing cities move as well. And we're seeing businesses move. More than 240 global companies have pledged to go 100% renewable, and more companies are adding their names and pledges to this list every single day. And hats off to the rising young generation, the Greta generation. They're leading the way. They see threats to their future, and they are demanding a better world as they have a right to do. I encourage you to join those who are using their voices, using their votes, and using their choices to fight for our future, our community, and our world. Use your voice, use your vote, use your choices in the marketplace and elsewhere as if your world depends on it. Speak truth to power because actually your world does depend on it.
Thank you. At this time, Bill, would you like to address questions or would you like to move over to the En-ROADS demonstration?
I can take questions at this time.
Wonderful. I don't currently have any to bring back to you from the Q&A feature, but I can hold on for a little bit to see if anybody would now like to take this time to ask. All right. So I do see one already. Bill, do you have any recommendations for climate change nonprofits to donate to?
I don't off the top of my head. I didn't anticipate a question like that. I know that some of these things will come out of the second part of this event tonight, the En-ROADS presentation. I think what we'll discover is that some ideas may come out organically. For instance, one of the realities of climate change is that each person living on this planet has an impact. Now, the reality is that that's not evenly spread across the globe. People who live in developed countries, especially the United States, we have a much larger impact than our fraction would allow, would justify. And if you go to some countries in the world, they have an almost zero carbon impact. But the idea of coming to some sort of terms with the population growth is still a good idea nevertheless. And one of the best ways to reduce population growth is to educate women. So there are charities that support the education of women around the world, and I would myself consider donating to some of those organizations.
Thank you. There have not been any more questions placed in the Q&A during your response. So if you are comfortable with moving on to the En-ROADS demonstration, if that's next, then I think that would be great.
Well, maybe as a little bit of a transition then between the
Sure.
two presentations, I was inspired to write a poem. And I have a little video of that, and maybe during this presentation of the poem, people might be inspired to come up with a question. Let's see how well this works here. All welcome to the great Earth Day. Respect and honor it, they say. Brother, sister, Mother Earth sustains us as we go our way. We recognize with shame the dearth we fain give back to this womb Earth, with little thought for its tomorrow and singular life-giving worth. Lack of gratitude gives sorrow, cannot pay back what we borrow. Too much focus on the fat, not enough on the marrow. Fear pins us on our comfy mat, stopping us from actions that correct the harms we've done for years. We're eating at the place we've shat. Those suffering are shedding tears. Collapsing livelihoods bring fears. Droughts are killing off their shade, their homelands turning into beers. What progress we humans have made, tame the earth with plans we've laid. Modern living builds a debt of exploitation's price unpaid. Fossilized carbon that we let escape its underground closet returns to us as rising sea and makes our riches salty wet. Weirder weather, can't you see, is setting fire to the tree, where many species, born and grown, will die because they cannot flee. Trashy piles of refuse drown the beauty of rich nature's crown. Grab, manufacture, sell, and toss, it does suffocate us, hold us down. We need not suffer any loss to save our grandkids from our dross. A better life is in our hands, mitigation's not a cross. Energy flows in our land, innovation is in our hand. A better life, sustainably, is a right we can demand. A better life, sustainably, is twice as rich and sets us free. Be not worried in this rat race that we'll go back up in the trees. Can we escape this madding pace and run away to outer space? Not Moon nor Mars could be our home. A next-door star we cannot grace. We're locked under a starry dome. No science yet can let us roam away from floods, droughts, fires, and ice that melts and runs into the foam. It's different now. Extremes, like dice, roll double sixes. Once, twice, thrice, within a year, a month, a week. We shake our heads, so high a price. We hold our tongues. We dare not speak against the profits that we seek. We must prophesy this hour. 'Tis not the time to be too meek. We must prophesy this hour. Muster courage, truth to power. Tell our leaders, let them know. Preserving life preserves the flower. 6 decades past, scientists showed the rising threat we've come to know. The president, though he did heed, felt we had time. First, let us grow. 4 decades past, we planted seed of action, but too small a deed. Opponents rose, a well-heeled crowd, but facts prevailed and gained some speed. 2 decades past, truth got a shroud of misinformers, boastful, proud. The data they could not deny, the scientists could not be cowed. Today we know the reasons why. Each passing year sets records high. We won't be safe in Babel's tower. Ignore the truth and we shall fry. We must prophesy this hour. Muster courage, truth to power. Respect the bee, respect the flower. Protect the bee, protect the flower.
Thank you for sharing that, Bill. I thought that was a wonderful poem. And it did inspire our attendees to ask a question, as you had hoped. We have a guest wondering if there are any countries that have yet achieved carbon neutrality.
I know that Costa Rica has put a lot of effort into doing that. They are a eco destination. I don't think that's the terminology they use, but they're very proud of their ability to preserve a very pristine environment. So I would imagine that they're very close to accomplishing that. I think that there's been a lot of progress made in the Netherlands and some of those northern European countries. I know that in Norway they've been having a very strong emphasis on electrification of cars. They have tremendous incentives there, and they are the #1 market in terms of per capita in the world. I think actually the #1 market for electric vehicles right now may be China. Last year, Europe had really great sales in electric vehicles. So there are a lot of activities that are going on around the world. I know also that there's a lot of large projects in China with solar installations that are square miles in size. I think I read about one that was 9 square miles you could see from space. So there's a lot of things that are being done. I don't have exact numbers to tell you of exactly how far each of these countries have gone, but the important thing is that, you know, they set a stake in the ground and they're moving toward that. So when they make a decision, it's going to be a decision that goes toward that stake rather than maybe taking a diversion that sets us back and you know, creates an investment in an area that if we're going to do the right thing, we have to throw away that investment, and that becomes an impediment. So I hope that here in the United States, we can set those same kind of goals. And then as people start to move toward them, they'll find that they're easier than they originally thought, and new ideas will come up and new inventions will happen. And, you know, we're all talking about reaching carbon neutral by 2050. I think, frankly, that that's far too late. But once we set that stake in the ground and say 2050, I think people will find ways to move toward that, and I believe we'll make progress faster than that.
Thank you.
Well, if you like, I can get started now on the En-ROADS presentation.
Yeah, I'm excited for it, and I know many of our guests are as well. So let's get going.
All right. What I'm showing here is the web page for climateinteractive.org. You can go out there yourself, write that down, climateinteractive.org. The En-ROADS model is a wonderful simulation tool that runs in a web browser on a computer. You can't run it on a phone or on an iPad. It has to be run on a computer. The amount of resources that it takes to run just don't exist on those other devices. But you can actually play with this model yourself. Now, what this is it uses a technology called systems dynamics, which tries to take into account all of the different interactions between lots of different things going on. As human beings, when we hear about solutions to climate issues, we might hear, well, we'll plant 1 trillion trees, or we'll electrify all cars, or we'll do this, or we'll do that. And it's really hard to do the calculations in our head to say, well, if we plant 1 trillion trees, how does that affect cars? Or if we electrify cars, how does that affect this or that or the other thing, right? And so all of these rules are written into this simulator together with the data from the heavy-duty science models that have told us what we know about where the environment is headed. And this is constantly being adjusted to make sure it continues to match with those heavy lifting models. But at the same time, it's presented in a way that we can adjust these controls and see a very quick turnaround, very quick responses. And in that way, play these what if scenarios. Okay, what if we do this? What happens? What if we do that? What happens? And we can work toward finding the kinds of solutions that are likely to solve the environmental destruction from climate change, greenhouse gases. Now, this is a model that applies to the whole world. It isn't really practical in this kind of computing environment to be able to break it down into individual regions of the world. So that's going to color your takeaways from this, but I don't think it's all that hard to say, well, at least we know that if we jump on the bandwagon with some of these solutions, that we're heading in the right direction, and it's likely to lead to the kind of outcome we need to have. So let's take a look at this model. Over here on the left, up at the upper left corner, we've got the sources of global sources of primary energy. This is measured in exajoules, and I think an exajoule is 10 to the 21 joules. A joule is 1 watt for 1 second. A kilowatt hour is 3.6 million joules. Okay, so these are really big numbers we're talking about, and this is all of the input energy, all of the coal in brown, all of the oil in red, all of the blue, gas in blue, Wind energy or renewables and solar and wind, they're the green. This pink color is bioenergy, and a very thin sliver on top of that is nuclear energy. In addition to those established energy sources, there's one called New Zero, and this is a technology that hasn't been invented yet. So for example, if Livermore Labs or whoever's working on fusion energy finally figures out how to make that practical, what would that do? We can play with that. We can say, what if somebody actually invents a totally new source of energy that we don't know about yet? So these are the way that energy flows into our environment. And then over here on the right, what we see is what happens with greenhouse gases. Now in this chart, you see a black line. That's the status quo. That's the trajectory we're headed on. The blue line surrounding it is what happens when we make the changes that we'd like to experiment with, okay? And then over here on the far right is where we expect the temperature to go. So we expect by the year 2100, and this model goes from the year 2000 to the year 100 years to the year 2100. We expect that the environment is going to be 3.6 degrees centigrade warmer, or 6.5 degrees Fahrenheit. And just for everybody's benefit here, I'm going to switch to US units. So 6.5 degrees Fahrenheit. Now down here on the lower left side, these are the energy supplies. So you can say, well, what if we put a heavy tax on coal? Or what if we actually subsidize coal? Where do we go with getting our energy from different sources? We can do the same with oil, natural gas, bioenergy, renewables, and nuclear, and this new carbon, zero carbon. We can play games with trying to tax the heck out of something to get us to do less of it. Or we can, for instance, with renewables, incentivize it and see how far we could go with building more renewables. And then this one down here at the bottom isn't the source of energy, but it has an impact on all those sources of energy. It's a carbon price. So if we say that, all right, we're going to measure how much carbon comes from coal and oil and natural gas, and at the well or the mine, we're going to add a price to that resource that will then flow into the economy. And we're going to start with a small number, maybe $10 or $15 a ton of carbon, and we're going to grow it every year, gradually making it more expensive to use those kinds of energy. And that will naturally urge people or nudge people towards solving the problem of climate change, solving the problem of the emission of greenhouse gases by changing the playing field so that it becomes relatively more expensive to continue to use fossil fuels and relatively less expensive to use energy sources that don't release greenhouse gases. So that can have an effect on all of these sliders, and that's why it's put in this block here. In the middle, we have a couple of ways that we use energy. We have transportation and buildings and industry, and then people and the economy. So we can do several things here. We can make our transportation more efficient by this slider. We can switch from traditional sources of fuel for transportation and switch to electricity. And then assuming that the electricity is getting cleaner, then what will happen? Maybe we'll solve some of these problems. Now, these things are broken down into their individual components. So for instance, if you make cars more energy efficient, that doesn't change how much of them are electrified. And vice versa, if you make them a lot more electric, it doesn't necessarily change how energy efficient they are. They are separate controls. They're presented as separate knobs to tweak. Buildings and industry, a huge sink for energy consumption and a huge source of greenhouse gases. So we can make buildings more efficient, and we can switch to electricity for those. And then in population, as I said earlier, every human on the planet has an impact. And so what if we had fewer people? And then, the engine of growth of the economy is we produce stuff which releases all kinds of greenhouse gases and uses up resources. And what happens if we slow down the economy? We could actually say we're going to slow down the economy, or we're going to try to speed up the economy and use that as a separate control. We can also see when we make some of these changes, what happens to the economy, all right? Then over here are some of the things we can do about greenhouse gases. We can change the way we're cutting down forests. So let's slow down deforestation or accelerate it. There's a little bit of room to accelerate it. Methane and these other gases like the refrigerants and so-called F gases that are manufactured for industrial purposes. Then what about planting trees? We used to hear about planting 1 trillion trees. That was kind of an initiative, in the past few years. What happens if we do that? How much of an impact does it have? And then finally, this slider here of technology. What if we invent a way to actually pull carbon out of the air so that we can continue to fly airplanes, we continue to drive cars and still burn all these fossil fuels, but we have a way of grabbing that and bringing it back out, the carbon dioxide, bringing it back out of the atmosphere and somehow storing it away permanently. Now, each of these, and this is if you want to dig into this yourself, each of these controls has these 3 little dots on here. And the dots allow you to drill down and see, okay, what are we talking about with this slider? For example, with coal, we can discourage or encourage mining coal and burning it in power plants. And then a little bit of explanation of why this is important. And then there are some microcontrols. Now, this model is built with experts in economics, experts in climate science, experts in economy, economics, sorry, I said that already. And they build in these well-known and well-established rules of how society moves, how the economy moves. But if you want to, you can go in there and you can tweak things under the covers and play games with, well, what if we had a moonshot kind of project and really put all our energy into something? Could we change those fundamental rules? But for example, with New Zero Carbon, it takes a while. If you discover something tomorrow, you can't expect that the world is going to be using that new technology the day after tomorrow. It's going to take years for plans to be made and plants to be designed and companies to spring up to provide the materials that are used in building these plants, and for the companies that build these plants to develop the expertise, and for the financial markets to get behind all this stuff. And like I said, economists know what these rules are and they're built in, but if we want to, we can go in here and we can tweak the rules and try to create a fake scenario just to see what happens. And then up on these charts, there's tons and tons of charts, lots of different ways you can look at stuff. And these 2 charts that are up here are just 2 quick examples of the kind of things that people like to look at. We have a quick collection of 10, 12 charts here that we can quickly go to. For example, temperature. What happens if we tweak something? What does the temperature do? And we can see the time effect. In the year from 2000 to 2020, these are the history. They don't change as we tweak the knobs, but we can look at them and say, okay, how does this new thing change that? And compared to the past, how realistic is that? There's a couple of dotted lines on here. The first dotted line is 1.5 degrees of warming in Celsius, or 2.7 degrees Fahrenheit. And the second line is 2 degrees of warming. And these are the targets that have been set by the Paris Accord. Okay, so that's a quick tour of this. Would anyone like to ask a question about what, one of these sliders that we could move? If you just shout out an idea that you have, something you want to explore, we can start talking about that and see if it meets what you assume. Johnny, would you like to?
Sure. Well, I'd also like to take this time both to encourage participation as well as connect this back to Milpitas's goals. I just shared in the chat with our panelists and attendees the link to our climate action dashboard, at which you can see the greenhouse gas inventory we developed for the community and explore the different factors or sectors of our city that are producing the most greenhouse gases, so that you can sort of imagine what actions we would need to take as a city to best address our carbon reduction efforts. So I've dropped that in the chat, but I'll say it as well, climateactionmilpitas.org. And it looks like we did already get a question from Adarsh. What do you think would be the most realistic way to slow down climate change? And then conversely, how about the most effective?
Most effective and most
realistic.
Well, typically what happens at the end of one of these facilitated sessions where people play with these knobs is this carbon price has a big effect. Now, the carbon price is something that's actually being tried around the world. British Columbia has been doing it for years, and it's been so successful there that the Canadian government has decided that all of the provinces will do it. They might not all do it the same way, but they all have a requirement to set a carbon price. The way this works, as I said, is you set a price and you gradually grow it over time. There was a bill in the House, the U.S. House, called HR 763. It's no longer current because of the new Congress, but it was called the Energy Innovation and Carbon Dividend Act. And the key word, one of the key words in there is dividend. The way this worked is all that money that gets collected, a lot of people would really be reluctant to see that go into government coffers and increase the size of government. The better way to do this is to take all that money and give it back to the people. Now, when they give it back to the people, they don't give it back based on how much money they spent on carbon. They give it back an equal amount for everybody. So I would get the same check as Warren Buffett would get. And the reality of our environment, of our economy, is that people at the low end of the income spectrum are spending less of their money on carbon. They spend less on carbon than rich people. And it makes sense, you know, rich people are spending more time in airplanes, they travel more, they have bigger homes, they have bigger cars. There are a lot of ways that they spend more on fossil fuels. So this has the effect of taking the people who spend a lot of money and build up that pool of dividend and shifting it to people who are at the low end of the spectrum. One of the things that's a big concern about the solutions to environmental destruction with climate change is that it's kind of a rich person's game, that poor people can't afford solar panels, poor people can't afford improvements that might make their homes more energy efficient. Well, this would help them. It would provide more money for them to spend. Now, they could take it and they could spend it to offset the rising costs of gasoline or the rising costs of electricity, because those things are going to get more expensive if they're based on fossil fuels. Or they could take it and they could use it to make some improvements, which then would have a kind of a spiraling down effect. One of the things, as they save money, one of the things that I think is really interesting is something called on-bill financing, where the utility would come into a home with some professionals that they'd hire to do this, that would look around the home and say, okay, you can save money if you do X, Y, or Z, and then find out where's the low-hanging fruit, the thing that's going to have the quickest payback, and then loan the money to make that improvement, which then lowers the utility bill for the resident. And then some of that lowered utility bill would then be added back as the payments on the loan that went into making the improvements. But from the get-go, people would see a lower utility bill. And then after a few years, that would be paid off, and then they'd see another drop in their utility bill. And what's really kind of cool about this is if you live in an apartment, you're not going to make improvements, you're not going to invest in it. Or even if you move, if you live someplace for a while and then you walk away from that investment. You have to think about that when you invest in your home. But the way this works with on-bill financing is that the loan and the payments stay with that home, whether it's an apartment or a house. You move out and you leave behind the utility bill. You leave behind the utility meter, and the next person who comes into that home and starts consuming energy and paying those utility bills is then going to pick up and carry on with that those payments. So it makes it easier to do more of these improvements. So carbon price, what does it do? Let's slide it a little bit. And because we don't have a ton of time, I'm going to take this in kind of high chunks. There's this cool little feature on here where you can place something in a loop. So I'm going to click that, and you're going to see that with and without that change. All right, we see that we have a big drop in oil, in coal. The brown one goes down. We see a drop in natural gas, the blue one, that goes down. We see a little bit of growth in the green one, renewable energy. We don't see a whole lot of change. Bioenergy is getting a little bit thinner. Nuclear doesn't change. Nuclear doesn't change based on a carbon price, which is kind of interesting because you might think that people would want to shift to more nuclear. Let's crank it up some more and do that again. Oh, let's do it all in one chunk though. Okay, play that in a loop. Now we see coal going way down, really getting squeezed. We don't see a lot of change in oil. There's some, but not a lot of it. We do see a significant change in natural gas and a growth in renewable energy. And let's take a look now at over on the right here of what happens to the temperature. As you can see, if we institute this carbon price and the defaults are set so that it starts this year and it grows for 10 years, it eventually reaches $158. So let's say it's $16 a year. And that's kind of the default based on what we just used on the slider. We see that the scenario has a ramping up here for 10 years from 2020 to 2030 as we go from no carbon fee to $158 carbon fee. And we see in the temperature that we shave off 1.4 degrees Fahrenheit or 0.8 of a degree centigrade. I mean, that's pretty dramatic. So let's just continue that and let's push that way out. Let's really hit that one hard, okay? I frankly, personally, I believe that this is something that is palatable once you get into it. People will understand it and accept it. But even with that, if you push it too hard, you're going to get some political blowback, right? But we can see that we can continue to have a benefit now, pushing it down to 2.6 degrees Celsius. We're getting toward that 2-degree goal. We'd really like to stay below 1.5 degrees because we know that there's a lot of effects, especially for the poorest regions of the world, if we go to 2 degrees. So we're overshooting that 1.5 clearly. We're going to have to do some more stuff. But look here, in 2020 to 2029, we don't really see much of a change. It takes a while before these things really start to set into motion. So we might look at, all right, what do we do to make that happen faster? Well, presumably the carbon price would lead to more people buying electric cars. But as I said, we don't automatically make that happen. We have a separate slider for that. So let's push for more electric cars.
One other thing that's being requested for a demo from an attendee is if you would be able to model as well or sort of toy with the building energy efficiency metric.
Very good. Very good. Yeah.
That's something
Buildings,
that's pretty important in our city as well.
and it is a tremendous sink, a tremendous draw on our energy needs. So what can we do with that? Well, if we make buildings more efficient, we see a clear drop in the energy needs overall. Interestingly, though, that doesn't have much of an effect on oil because we do a lot in our buildings with electricity and natural gas. So we do see a reduction of natural gas. Now, if we go to more electrification,
and electrification would sort of be the contrast to the status quo of using natural gas for much of our home heating.
right? So going to heat
Okay,
pumps, yes.
that's important as well. For those who have looked at our dashboard, 27% of greenhouse gas emissions from our city come from natural gas use in our buildings.
Okay, 27%.
I would just like to say, if any of the attendees, if you want to ask Bill directly something to model or question, you can raise your hand and we can unmute you, since this is the interactive part.
Absolutely, that would be wonderful.
Yeah, Bill, just for some info for you, according to our most recent greenhouse gas inventory undertaken as part of the Climate Action Plan, far and away the biggest contributor to greenhouse gas emissions in Milpitas is on-road transportation at 61%.
61%, okay.
Yeah, followed next by with the other significant chunk being natural gas at 27%.
And that's for buildings.
That's right. Fortunately, we did join a CCA, Silicon Valley Clean Energy, in 2018, when 97% of our residents have opted to join in. So we now have carbon-free electricity for our homes. But natural gas is the big kicker.
All right. Well, one of the things we can do is we can reset everything with the click of a button, and we can play with just that. So let's make our buildings more efficient. And you can see that by making them more efficient, we can dramatically reduce the amount of natural gas that's consumed. Interestingly enough, that doesn't really happen until about 2050. We don't see a big divergence. So let's try electrification.
And to answer another question from Adarsh, this is an internationally based simulation, correct?
Right.
So
yes.
This goes to say that I guess when you slide electrification all the way to the right, that means that not only is all new construction all electric, but it's also a full conversion of existing buildings to all electric as well, right?
We can look at the inside here and see what sort of assumptions are built in. So we increase or decrease the use of electricity, and we just increased it, instead of oil and gas in buildings, appliances, heating systems, and other machines. Using electric motors only helps reduce emissions and improve air quality if the electricity is from low carbon sources. Okay, so one of the reasons we didn't see as much of an effect right away is because we haven't done much with where we get our electricity from. So if we push renewables up and we push, well, let's just try this carbon price. Let that do the job for us. Now we can see that we're getting more of an effect. I'm going to put this back and move it as 1, and then play the loop. Not only do we have a much bigger effect, but it comes much sooner. Now we see this big inflection here at 2034, or even earlier, 2030-ish. time frame. So we want to push for, let's try just seeing if we can isolate this. More renewables, less coal, less oil, less natural gas. More nuclear? That doesn't seem to have a whole lot of effect. So let's pull that oil down by electrifying cars, because you said that was the second most important thing, right?
In our community, that's the number one.
In Milpitas, yeah?
Yeah.
Okay. So we're coming down. We're making a dramatic difference here. Let's see if we can make this more efficient. We'll really focus on the carbon price. We'll really focus on electrifying cars and buildings and making them more efficient. Be a little bit less dramatic on those. And maybe we even give a kicker to renewables. All right, how are we doing here? We're getting to 2.3 degrees Celsius, getting closer to that 2-degree target, still way above the 1.5 degree Celsius mark. And we're seeing things start to change in around 2030 again. So what else could we try?
If anybody in the audience would like for us to test any other metrics as well, feel free to let us know, either through the Q&A or through raising your hand.
I guess one discussion question, Bill, while we wait for audience members, is what lessons do you think we can take from the COVID-19 pandemic to the climate, to all the climate change impacts that are happening now and will increase to happen?
Well, people got really excited about the drop in pollution and even the drop in carbon dioxide releases because of the reduced amount of travel that people were doing. When we were staying home and we were doing more remote meetings, right? And so our energy needs dropped, and in particular, nitrous oxides, which is a greenhouse gas, a short-lived greenhouse gas, but a significant one that also has health impacts. Those things dropped, particulates dropped. We started to see the air clear in many parts of the world. So I think what that says is that, we don't have to accept things the way they are. We have a clear example that things can change pretty dramatically in a relatively quick amount of time. Now, the reality is that having a pandemic from now to eternity wouldn't solve the problem. We still have a substantial amount of releases of greenhouse gases. And so, for example, we could take a look at afforestation that was mentioned by one of the participants. This is the idea of planting trees, okay? There are a lot of challenges to doing this. We have to acquire the land, and that's going to take some money. It may require some political dealing, because people whose land is being used for one thing, convincing them that they should make it into forest, and they could, and then keep it as forest, because if they don't keep it as a forest, the trees will grow and they'll sequester carbon. But if they cut down the trees, then that's just a temporary solution. It has to be one that's more permanent. One of the ideas is that indigenous people who live in forests are very good at managing forests. They use a particular kind of agriculture that involves burning small areas to clear the land for farming. But then after just a couple of years of growing things in that land, then they let it go back to forest. And in the process, it goes through several phases where it really enriches the environment with a lot of biodiversity. So that would be one idea. And that, somebody was asking about how could you invest in something that would help. If you're looking for a charitable investment, you might consider donating to organizations that help allow indigenous peoples to maintain their lifestyles and have control of the forests that they live in. So afforestation, let's say well, let's take a look at what it describes here. It says, plant new forests and restore old forests. As trees grow, they draw carbon out of the air, which reduces the concentration of carbon dioxide. However, without care, large-scale afforestation can compromise biodiversity and historical land rights. So again, that idea of letting the indigenous people do what they've been doing for so long. How much land we might use, that's one of the sliders. When we start doing this, how much time it takes to actually procure the land that we're going to plant on, and how long it takes to plant the trees. All right, so that's the background. Let's go ahead and move that slider up. And I'm going to reset this so we can see it all by itself. Let's move it halfway. And we see a very minimal change. 1/10 of a degree Fahrenheit. It's in the rounding error for Celsius. And it's hard to even see this move, but there's a little bit of a bend somewhere out here. All right, let's go farther, all the way out. Plant as much land as we can possibly imagine. And what do we see? Just 2/10 of a degree Fahrenheit, 1/10 of a degree Celsius.
Would you likewise be able to pair that with a slight reduction in deforestation?
Okay, good question. Deforestation is really kind of critical because especially like in Indonesia, where they're clearing the jungle to grow palm trees for palm oil. Not only do they cut down the trees, but then they set it all on fire, and there's meters of carbon buildup that's sequestered in the forest floor or the jungle floor, and all of that burns and releases into the atmosphere. So it's a tremendous amount of carbon dioxide released, and if we could slow that down or stop it, that would be really dramatic. We also have a lot of deforestation in South America, in the Amazon, in land that isn't particularly good for growing anything. And once you cut down the forest, it's really quite difficult to reestablish it because it's not the greatest land to be working with. Here you see somewhat more dramatic effect. Another thing about planting trees is, they don't start really sucking up carbon the day you plant them. It takes years for them to grow to a big enough size that they're really significantly absorbing a lot of carbon dioxide. And then they only have a certain life. And when they die, they're going to fall and they're going to decay and they're going to release carbon back into the environment. So there is a limit, an asymptote, if you will, of how much carbon dioxide you can sequester in a forest. When you hit that limit, that's it. So we have added a lot of carbon dioxide that's come out of the ground, and the trees just can't absorb that. We can restore the trees back to where they were, but we can't get them to go farther than they used to go and solve this problem for us. But so we push deforestation all the way. Let me reset these. Do them in one fell swoop so we can use that loop and play it and see, all right, we can actually drop the temperature 2/10 of a degree Fahrenheit, 1/10 of a degree Celsius. And we see that happening it's interesting the way these sliders are working. Maybe I'll do it like this, reset it and then watch it. There we go. That's one more smooth motion. From 6.5 degrees Fahrenheit to 6.2 degrees Fahrenheit, 3.6 degrees Celsius to 3.5 degrees Celsius. And the change occurs really beginning around 2045, 2040, 2045. It takes a while for that to happen.
Yeah.
Good things to do, undoubtedly, but
Certainly.
don't expect them to solve the problem quickly.
Additionally, would you address the potential impact that population can play? I know many
Okay.
lower and middle income countries are quickly seeing declining birth rates and sort of like peak childbirth already as is. Obviously, those populations will still swell even if birth rates were to quickly decline just due to the large bump that's already occurred. But could you address population in the simulation too?
Okay. Let's read what it says about that. Assume higher or lower population growth. While there is an expected trajectory of population growth, there are steps like women's education and access to family planning that have been shown to accelerate shifts to smaller families, which would slow population growth. We have 10.9 billion people expected to be on the planet in the year 2100. Help me with this. I think we're somewhere around 7 to 8 billion now.
We're quickly approaching 8.
8. Okay. So there's already an assumption. I need to open that again. You can see this population growth curve here. There's already an assumption that population growth is going to flatten out. But what if we try to accelerate that? Let's see if we've got on this quick chart here. Can I pull up the population? No. Let me, oops. All right, it's still showing. Sorry, I'm having a little bit of a technical problem here. Go back to the default graphs. Look at population, global population, and slide that.
So this is with higher forecasted growth.
Here's lower.
Okay.
All right. So we put a lot of effort into encouraging people to have lower families, little smaller families. And we do see that the global population reaches a peak here, somewhere around 2065, 2070, and then starts to decline. The effect on the temperature was 0.2 of a degree Fahrenheit, 0.1 of a degree Celsius. So again, it's not a substantial change. And I want to say something about population. You know, we have a lifestyle in the United States where if everybody in the world lived the way we do, we would need 5 worlds to absorb all of the waste and to provide all the resources that we use in the West. So as the world develops, countries, small countries, poorer countries, big countries, I guess, but poorer countries, they want to get to the same standard of living. They want to see their lifestyles improve. So that's going to somewhat counteract the effect of having smaller population. But looking at this in population by region, I think is an interesting chart here. Developing countries, they represent really a lot of the growth in population in the world. Here we are in the United States, we're red, we're pretty much flat. China is in decline. India even is coming to its peak and is expected, well, that's with these population influences. But even without, you can see that most of the change is being done in the developing countries. And as you might imagine, since they're not having that big of an effect on climate right now, the benefits of reducing those populations is less dramatic than you might think. I think we're coming to the end of our time, aren't we?
We are, yeah, we have about 4 minutes left, but
Okay.
I think that what the big takeaway for me has really been is that not any one of these solutions brings us to the goals that we've set for ourselves. If you want
Absolutely.
to speak to that a little bit,
You bet.
and yeah, help us like figure out what to do with this information now that you've shared it with us.
There's no silver bullet, but there's lots of silver buckshot. That's what they like to say, right? But I think if we put a lot of emphasis on carbon price, I'm just kind of going to go to a solution that I've seen, and we spend a lot of effort on this thing we haven't really talked about. Methane has 20 times the effect on the environment that carbon dioxide does. And these other gases, these so-called F gases, which are manufactured gases, they have a substantial impact in terms of the amount of warming per unit of gas, per molecule of gas. And so if we really pay a lot of attention to that, we can have an effect. We have to have, of course, electrification of buildings and industry, and we should at least spend some effort on making things more efficient. You see now we've hit that 2 degree centigrade target. If we then add in some deforestation reduction, some afforestation advantage, and some way of pulling carbon dioxide out of the atmosphere, we can actually reach the 1.5 degree goal. Now, I'm going to reset the graphs here, and didn't that work? Return to defaults. You can see we are dramatically dropping the greenhouse gas emissions. We're actually crossing the zero line here around 2075, 2070, and we're actually beginning to go negative, which is an essential part of having a sustainable world for the long term. We put a lot of greenhouse gases into the atmosphere through non-natural means, and so we can't expect them to come out of the atmosphere quickly with natural means. We've got to go beyond that. And then when we look at the temperature, here we go. We are here in 2021. We're already 2.3 degrees Fahrenheit, roughly 2.3, 2.4 degrees above pre-industrial temperatures. We're going to continue to climb, even with all these measures, reaching a peak that exceeds 1.5 degrees or 2.7 degrees Fahrenheit. And then around the late 2040s, we start to come down. Now, I think what's really important about this is in order to meet these goals, we cannot afford to wait until 2050. We're hearing a lot of people talk about setting goals for 2050. We're hearing a lot of people say that's not way not fast enough. We need to be setting these goals for 2030. And I'm 100% in agreement with that. So we need to take advantage of all of the actions that are in play already today, and we need to advocate hard for much, much stronger actions. Now, what's really, I think, key in this message as we go out, because a lot of people just focus on economics, is that we don't really see that this hurts the economy. In fact, if we had more time, we could dig down a little deeper into this and see that if we don't address climate change, it actually hurts the economy. And addressing climate change, especially with the carbon fee and dividend, it infuses capital in and it spurs innovation. It creates a lot of new economy and a lot of activity in the conversion of these systems. And so we actually see a growth in the economy. So that's the message we can use to sell this, is to go out and say economic development will come from these things, not from the avoiding of these things, and try to change people's mind based on the economics. And we have some good examples of that today.
Like it would be equitable growth as well, with the talk of the dividends helping spur investment in the economy from high, low, and middle income residents.
You know, another idea that popped into my head about where could you invest. If you've got the money to invest, you might consider investing in this on-bill financing. So the way that's going to work is that the utility is going to administer it. They're going to charge for the payments, right? They're going to collect the payments against the loan. But they have to go out to somebody to get money to finance it. And they have to work with companies who are going to perform the services of doing the energy audits and developing the improvements to homes and buildings, businesses. So if you have some money to invest, you might consider investing in the financing, providing the loans. I'm not sure if that's available or not, but
well, thank you for that. At this point in time, Bill, we are past the time allotted. If our residents and attendees have any more questions for you, are you open to be reached at a later time?
Absolutely. I will give an email address that you can reach me here. Oh, I mistyped that. Anyway, at gmail.com.
Okay. I do believe that was just shared with the panelists. So I'm going to copy and paste that for the attendees as well.
Okay, thank you.
My pleasure.
The most important thing that people can do, and I want to close with this, is to just talk about it. Go ahead and get a copy of this. Go out to the website, start playing with it, develop your own story, and talk about it. That's the most important thing we can do, because we have to build the political will to make the changes we have to make.
All right. Well, thank you. It was a pleasure hosting this event with you tonight, Bill. Happy Earth Day to you, to all of the Milpitas staff on this call, and to all of our attendees as well.
Thank you, Johnny. Thank you, everyone. Have a good night.
You as well. Thank you. All right.